Hello, in this lecture we will find the radius of the circle enclosed in a triangle. As you can see in the drawing, we have triangle ABC, and inside the triangle we have a circle. We know that side AB of the triangle ABC equals to 4 units, side BC of the triangle equals to 3 units, and side AC of the triangle equals to 5 units. And we also know that the area of triangle ABC equals to 6 units. And we want to find the radius of the circle. Okay, let's define the center of the circle as O. So point O is the center of the circle, and let's define the touching point between the circle and side AB of the triangle as N. So point N is the touching point between the circle and side AB of the triangle ABC. Or we can also say that side AB of the triangle ABC is tangent to the circle at point N. And in the same way, we will define the touching point between side BC of the triangle to the circle as M. So point M is tangent to the circle, or we can say that side BC of triangle ABC is tangent to the circle at point M. Let's define the touching point between side AC of the triangle to the circle as point P. Or we can say that side AC of the triangle is tangent to the circle at point P. Okay, so actually line segment MO is the radius of the circle. So I will mark it as small r, because it starts from point O, that is the center of the circle, and ends at point M, that is a point on the circle itself. For that reason, the line segment MO is the radius of the circle. Okay, in the same way we can connect points N and O together by a straight line, and for the same reason we can say that line segment NO is the radius of the circle, because it starts from the center of the circle and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of the circle. Okay, and we'll connect points O and P together by a straight line. So line segment OP is also the radius of the circle, so for the same reason, because it starts from the center of the circle, that is point O, and ends at point P, that is a point on the circle itself. So we can say that line segment OP is the radius of the circle. I will mark it as R, and ON, as I already told you, is also the radius of the circle, so I will mark it as R, small r. Okay, so actually in this drawing we have three tangents to the circle. Side AB of the triangle is tangent to the circle and also is tangent to the radius at point N. Side BC of the triangle is tangent to the circle and is also tangent to the radius at point M. And side OP and side AC of the triangle is tangent to the circle and to the radius at point P. Okay, so but actually we have a rule. I will call it rule number 1, that states that in any circle a radius and the tangent to the radius are perpendicular to each other. So I will read rule number 1 again. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius is perpendicular to its tangent. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually we can implement this rule in our drawing, because we actually have here 3 radiuses of the circle, and we have 3 tangents to those radiuses. Side AB of the triangle is tangent to the radius, to the circle, and also to the radius at point N. For that reason, according to our rule number 1, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. Okay, and from the same reason, side BC of triangle ABC is tangent to the circle at point M, and is also tangent to the radius. For that reason, according to the rule number 1, angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. Okay, and also side AC of triangle ABC is tangent to the circle, and also is tangent to the radius at point P. Therefore, according to rule number 1, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay, so we have here 3 or you can say 6 angles that equals to 90 degrees. Now we will connect points O and C together by a straight line. And we will also connect points O and B together by a straight line. Okay, so we will focus on triangle BOC, that in the green color. So the triangle in a green color, BOC, if we want to calculate the area of this triangle, as you remember, the area of any triangle equals to the base of the triangle times the edge of the triangle, or the height to the base, to the base, divided by 2. Okay, the area of any triangle equals to the base times the height to the base divided by 2. So actually, if we want to calculate the area of the green triangle, we can say that actually it equals, I will mark, I will say that the area is A, it is abbreviation for the area, so the area of the green triangle will be equal to the base of the triangle, that is equals to 3 units according to what is given us in the question. The base of triangle, the green triangle OBC equals to 3 times the height. The height is actually the radius. Okay? The height is the radius of the circle. The radius of the circle that is inside the triangle. So the height to the base equals to the radius of the circle divided by 2. So the area of the green triangle equals to the base, that equals to 3 units, times the height, that equals to the radius of the circle, I marked it as R, divided by 2. So it is actually 1.5 R. Okay? 3 over 2 is 1.5 times R. Okay, so actually the area of triangle BOC equals to 1.5 R. Okay, the area of the green triangle BOC equals to 1.5 R. Okay, because 3 divided by 2 is 1.5, and we multiply it by R, so it is 1.5 R units. Okay, now we will connect points O and A together by a straight line. And we will focus on the yellow triangle. So actually the area of the yellow triangle, that is AOC, will be equal to the base of the triangle, that equals to 5 units, times the height of the triangle that is actually equals to the radius of the circle. So it is 5 times r divided by 2, yes, because the area of any triangle equals to the base times the height to the base divided by 2. And the base equals to 5 units, the height equals to r, so it is 5 times r divided by 2. Okay? So the area of triangle AOC equals to 5, that is the base of triangle AOC, times the height, that is the radius. The height to the base is the radius, so it is 5 times r divided by 2, according to the area of a triangle. So 5 divided by 2, or 5 over 2 equals to 2.5, so it is 2.5 r, or we can say that the area of triangle AOC equals to 2.5 r. Okay, the area of the yellow triangle AOC equals to 2.5 r. R is the radius of the circle. Okay, so in the same way, we will calculate the area of the pink triangle. Okay, so the area of the pink triangle, that is triangle AOB, the area of triangle AOB will be equal to the base of the triangle, that is 4 units, times the radius times the height of the triangle, or the height to the base, that is the radius of the circle, divided by 2. Okay, so the area of any triangle equals to the base times the height to the base divided by 2. So the base equals to 4 units, and the height to the base is r, the radius of the circle, divided by 2. Or 4 over 2 is 2. So actually the area of the pink triangle AOB equals to 2 times r, the radius of the circle. Okay, the area of the pink triangle equals to 2 times r, the radius of the circle. So the area, or the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the pink triangle will be equal to the area of triangle ABC. Okay, so we can write that the area of triangle ABC will be equal to the area of triangle BOC, that is the green triangle, plus the area of triangle AOC, that is the the yellow triangle, plus the area of the pink triangle, that is the actually triangle AOB. I will mark it as equation number 1. We can say that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the pink triangle. Okay? But we know, according to what is given us in the question, that the area of the big triangle ABC equals to 6 units. So we can write it down. And the area of triangle BOC is 1.5 r. The radius r is the radius of the circle. The area of triangle AOC is 2.5 r. And the area of the pink triangle equals to 2 times r. Okay, so in total we got that the area of the big triangle ABC equals to 6 units, and it is actually the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the pink triangle. So we have here 6 equals to 1.5 r plus 2.5 r plus 1.5 r plus 2.5 r equals to 4 r, and 4 r plus 2 r equals to 6 r. So in total we got that 6 equals to 6 times r. Okay, 6 equals to 6 times the radius of the circle, because 1.5 r plus 2.5 r equals to 4 r, and 4 r plus 2 r equals to 6 r. So we will divide the equation number 1 by 6, and we will get that the radius of the circle that inside the triangle ABC equals to 1 unit, because 6 divided by 6 is 1, so r equals to 1 unit. Okay, r equals to 1 unit, and the radius of the circle that inside the triangle ABC equals to 1 unit. Okay, so the answer to the question is the radius of the circle inside triangle ABC equals to 1 unit. Okay, thank you very much.